We use different speeds while exploring the texture, but our perception of its identity remains constant. At a neural level, our sense of movement is fused with a proportional change in the temporal frequency of vibration, preserving spatial constancy. When rendering such textures virtually with vibrotactile variables, we need to modulate the temporal frequency of vibration as a function of measured sliding speed. However, continuous frequency modulation can be hard to implement in vibrotactile actuators, as their amplitude response varies strongly with frequency. Modulating amplitude at a given frequency, however, is easier to implement. In this paper, we present pseudo-frequency modulation, or PFM. We use speed tracking to create envelopes for the velocity amplitude of low and high frequency vibration, using which a net superimposed signal is generated, which is sent to the device. This creates an illusion of continuous frequency change. We used spatial frequency as a design parameter to create distinct textures. It controls the speed at which the signal transitions from low to high frequency. For example, in a coarser texture, this transition happens at a higher speed. In a psychophysical study, participants described a continuous change in frequency while interacting with the PFM texture. When compared to a single frequency texture, they rated PFM as more natural, associating it with real textured surfaces like Velcro and breadboard. We found that participants can distinguish 3 PFM textures even though they are composed of the same single frequency components, implying that we can create diverse virtual textures using only 2 single frequency signals. Finally, we found that visual representation of textual features complements the PFM-based haptic display, suggesting potential of integrating PFM with visual feedback.